so in our previous segment, we talked about what a force was. A force is a push or a pull. So now we want to talk about what energy is. So we're going to abbreviate energy with the letter E, capital letter E, and then the official metric unit for energy is going to be called the joule, and then we abbreviate joule with the capital J. And again, if you're from America, then the English, one of the English units for energy might be the calorie. So when you get a cereal box, you notice how many calories of food are you eating, because that food is going to turn into energy. So one of the units for energy in the English system of units is going to be called the calorie. So exactly what is energy? It's actually harder to define than what a force is, because you can feel a force. You can feel when somebody pushes on you or they pull on you. That was a force. Energy is a little bit harder to define, but you know that if you put gasoline, petrol, into your automobile, that you'll notice that it has energy in the fuel, because what does it do? When it explodes, it can cause the pistons to move, which can cause the tires to move. So that energy is going to be something that we're going to give to something that causes that something to do something. All right, so that's going to be our definition of what energy is going to be. And I want you to have an idea for the different kinds of energy. So that starting off down there at the bottom, you've got chemical energy. So when atoms rearrange themselves, that can give off energy. And so we've already talked about food containing energy. If you strike a match, that's a chemical reaction that releases energy. Then next to it is electricity, because you know that electrical energy goes into your house to make your lights run and so forth. And then like when lightning strikes, that lightning bolt has a lot of energy. Okay, next to it is going to be light energy, which we're not going to do a whole lot with that in this course. But you have visible light, infrared light, which is another name for that, is heat. Even radio waves have energy. Then you got thermal energy, and so it takes energy in order to change the state of something. So if you've got ice, which is a solid, you need to heat it up, and then that will cause it to change into a liquid. So that would be a form of energy when it changes its state. And then another one would be a bowl of soup contains energy when it's hot. And so that's another kind of energy storage. We're going to find out that's very important with the Earth. So the Earth is like 70% water. And then sunlight, so light energy, heats up the water and is stored in the oceans, and then that affects the climate. Then next to it is two kinds of mechanical energy, so that you have kinetic energy, which is energy of movement. So when a car is moving, it has kinetic energy. That energy comes out when it crashes into another car. Okay, then you also have potential energy. So we're going to be talking about gravitational potential energy. So like for example, if I take this pen and I hold it up here, it has energy. It has the potential to do something. So this would be called gravitational, it's caused by gravity, potential energy. And if I let it go, okay, did you hear that? So it was turning into kinetic energy because it was moving, and then when it hit the tabletop, it made the tabletop vibrate and give off sound waves, which contain, you heard it, energy. Then next to it is nuclear energy, And so both of those are very important. Our sun uses nuclear fusion, so that hydrogen is smashed together and turned into helium, and that gives off energy. So that's called nuclear fusion. That energy comes to Earth in the form of light, and then that helps to keep our planet warm through the greenhouse effect. Then you also have nuclear fission, where you start with a big nucleus like uranium, and then when it breaks apart into two smaller nucleuses, it gives off heat. And so that's how all the nuclear power plants on Earth currently operate, is through nuclear fission. So those are all different ways of producing energy. Okay, well, let's go ahead and do this one. So potential energy, we said, is the energy of position. And we said if we hold this thing up, it's got potential energy. So there's a certain height, h. This thing has a certain mass, m. And then its subject, it's being pulled on by gravity. And so the formula for potential energy is going to be the mass of the object multiplied by the height off the ground, and then multiplied by gravity, which we call the acceleration due to gravity, g. But there are other kinds of potential energy as well. So you also have elastic potential energy, like with a bow. So when you pull the bow back, there's a certain distance that you're pulling it back. Just like you raise this a certain distance. So the further back you pull the bow, the greater the distance and the more energy you give the arrow when you let it go. Then next to it is chemical potential energy. And that's because there's a certain distance between two atoms, and they are being pulled together by electricity in the same way that this thing is being pulled towards the Earth by gravity. In chemical reactions, it's the electrical force that is causing that potential energy. And then that energy can be released in a chemical reaction. And then next to it is nuclear potential energy, where inside the nucleus of the atom, you've got protons and neutrons, and they are subject to the nuclear force. And depending on how far away they are, you have nuclear potential energy. Okay, and then let's go ahead and do this one as well. We mentioned what kinetic energy is. So energy of motion, and it depends on your speed. So the faster you're moving, the greater your speed. And we give speed the letter V for velocity. So the greater your speed, the greater your velocity, the more kinetic energy that you're going to have. And it also depends on your mass. So you could either be run into by a bicycle going at 10 kilometers per hour or a truck going at 10 kilometers per hour. Well, it's going to hurt a lot more with the truck because the truck has more mass. So just remember that kinetic energy depends not only on how fast you're going, but also on what your mass is. And then lastly here, energy cannot be created or destroyed. So that the sun gets its energy from the smashing together of individual hydrogen atoms. So potential energy is going to be turned into this nuclear energy of fusion. That in turn goes into light energy that is transported to the Earth. That in turn can be turned into chemical potential energy in a plant. And then when you eat that plant, you can get that energy out, And then when you pedal on a bicycle, that energy comes out of your muscles and then can be turned into kinetic energy of moving the bicycle. So energy can be transmitted, energy can be changed from one form to another, but you can't create it and you can't destroy it. All right, let's take a break. And when we come back, we're going to talk about the origin of the universe.